Hi, my name's Andrew Broughton. I live in Airdrie, Alberta, and I've been doing live sound my whole life. My current and latest gig is Rain, a tribute to the Beatles touring show. Been with them for 11 years, and we'd probably still be out right now if it wasn't for COVID. I'm also a computer programmer. I enjoy software that does automation, control systems, things like that. My latest work has to do with controlling mixers over the internet. I've also written some companion modules for controlling Yamaha and Allen and Heath consoles. And yeah, like that. Always interested in learning more. And if you're interested in anything I'm doing, check me out at www.checkcheck12.com. That's all spelled out in letters, CheckCheckOneTwo. That's my site, and thanks for listening.
AV Tech Talks, House Rules. Join us on AVE Live, Mondays at 7 p.m. Eastern Standard Time. Join us on Zoom. Watch on Facebook or YouTube from the AV Educate page, or register as an attendee for the webinar. Live Q&A. Our guest will lead us through a guided demo and conversation about tonight's topic. We will take your questions and comments throughout the show. Don't wait until the end. Get your questions and comments in early to shape the conversation. We don't know it all. We're human and don't claim to know everything. We may demonstrate or discuss one way to do something, but that doesn't mean it's the only way to do it. If you found another way that is easier or yields better results, please share with the community so we can all learn together. Follow AV Educate. We're on Facebook, Instagram, and have a library of content on YouTube. Join us on Zoom for AV Tech Talks and to become a member of our community on Discord, where the conversations, the learning, and the sharing continues. We are where you are. Place your phone over the QR code to come learn more about AV Educate.
And welcome to AV Tech Talks. Thanks for joining us. We are in week 2 of Audio Month, April's Audio Month here on AV Tech Talks. So we are talking today about cables and connectors. We've brought together a great panel to help us out, and we're going to talk about the common types of cables and connectors that you might see in the audio world, as well as some of the fringe case uses. We've brought, I think there's been a smattering of different types of cables and some, I think we might have tried to one-up each other on what rare things we could find, some of us. So yeah, we'll be showing some of that stuff. As always, get your questions and comments into the chat wherever you're watching us. If you're watching us on Facebook or YouTube, put it in the comment section. If you're here in Zoom with us, put it into the Q&A feature at the bottom of your screen. We'll get to those questions live during the show. And so with that, I want to first get my outline open so I know kind of what order we were going to look at this stuff in. But I want to welcome our panel. We have a couple new faces. I don't think Marty's joined us on the panel before. Leo's been here, I think once or twice. And then we're welcoming back Jason and Brian, Andrew, Justin, and Andrew. 2 Andrews. Have we not settled on an Andrew naming convention for you guys yet?
All right, I'm changing my name to Andy for this call. Sorry.
Excellent. He called it first.
Beat him to it.
You beat him to it this time. Exactly. Great. So, yeah, why don't we start with looking at connectors? Oh, actually, sorry, we should start looking at a little bit of terminology before we get into that. Do you guys have that outline? Any of you guys, if you pulled it up on the drive? If not, I'll kind of go through it. let's talk about how we label. How we label our connectors. As far as how do we know which end plugs into something? What's a plug? What's a jack? What is male? What is female? How do we know, and what can we show maybe as an example if anybody has one? Has one ready? Marty.
I actually do have one. We have several different types of connectors here, and first up, the most prevalent microphone kind of connector is an XLR, and if you see pins at the inside the shell, it's a male. If you see holes, it's a female. They come in 3-pin, 4-pin, 5-pin, 6-pin, 7-pin, but microphones and line level devices are generally 3-pin. And we name the pins just like on any other connector, usually positive, negative, and shield. And XLRs are generally mono devices, but in special cases, they can be used for unbalanced stereo. So we have XLRs, and then we move into quarter-inch connectors. Quarter-inch connectors are like guitar connectors are tip and sleeve, and headphone connectors and stereo connectors and balance connectors would be tip, ring, and sleeve. I'm sorry, I said guitars are tip and sleeve. That's correct. Yeah, tip and sleeve. We have mini plugs or 3.5 millimeter plugs or small headphone style connectors. Pretty much follow the same convention as quarter-inch connectors. Then we have RCA connectors, which are actually kind of coaxial connectors, which means that there's 2 wires and the center pin is in the center and the shield is around them. Sorry, you can't see my cursor here because of the nature of this document. That kind of names these kind of major connectors.
Cool.
We see your cursor. No problem.
Oh, good.
Good to show that.
Yeah, no, that was great. Thank you, Marty. So going back to that basic kind of terminology, as you mentioned, if there's pins, something that's sticking out, we refer to those as female. As male. And if there's holes, we refer to those as female type of connectors. You mentioned something called tip, ring, and sleeve on the TRS, the TS and TRS connectors. Maybe somebody could talk to us about shielded versus unshielded cabling briefly. You know what? Why don't we stick with connectors first? Actually, now that I'm looking at this, let's go with some more connectors. So Marty showed us a couple of the most common ones, being XLR and quarter-inch. There's a lot of uses for XLR. So besides microphones, there's pro audio. So if you're doing line level, connecting between 2 pieces of gear, for example, the output of a mixer to the input of an amplifier, maybe, or a powered speaker. There's a bunch of other uses. Justin Herminghaus, in your world, what do you use XLR for with comms? I'm thinking
everything and anything. I mean, line level audio, mic level audio. You can get anywhere from 3 up to 6 connectors. The best of my knowledge, lighting is using it. DMX, the big 3-pin, 5-pin controversy. You see it on fog machines. You see it everywhere. I mean, basically anywhere you need a robust, easily repaired connector. Anybody who remembers good old Bose speakers, you've even seen them used as speaker connectors. So it's really the utility go-to. And even if you're not using the XLR version, just the shell itself, we get to talk about things like EtherCon, where it basically becomes a carrier for data connectors. So it really is just the general utility connector format.
AES as well.
Yes.
AES3.
Jason, can you tell us what AES3 is?
Digital transport specification for stereo audio. One connector and cable carries left and right both.
And that's a digital signal.
Yes. Yes.
Great.
Alex,
And I have a lift gate that has a control pickle with an XLR3 on it.
Really?
Yeah.
That's
I had
funny.
I had an electric bicycle I used the end of last year for 4 months when I was in California that used an 3-pin XLR for the power connector, the charger connector. It was like
Old-
perfect for an audio guy.
old Soundcraft used to use an XLR 2-pin for power. Strange little connector.
Well, actually, video, you see a lot of 4-pin XLR power as well.
This may be a good place to mention too that in power systems, electricity flows from female into male, whereas with microphone and line level audio, we flow into female and out of male.
Only for safety. So because you can't stick your
Correct.
finger in the female
Right.
end of it typically.
And
Yep.
what does XLR stand for?
Oh,
Ooh.
I know this.
Ooh,
I
I'll
know what
take that
A-
if no one else does.
And I had to pull up 2 different sources, which are totally different, by the way, for that. But go ahead.
it's just
Version-
lawn lumber, right?
Yeah, the version I got is that it's from Canon, who makes it,
Yeah.
and they numbered all of their connector types sequentially. So when they got to this one, it was the X series. And originally they made them with sort of a hard phenolic insert, which had a bad habit of cracking, and they tended to come apart. So they started with the X series connector, and then they added a latch to it so it locked. So that became the X series locking version. And then they changed that crappy phenolic insert that always crumbled and replaced it with a rubber one. So is the X series locking connector with the rubber insert.
Does anyone know what the mil spec designation is for XLR? A3M and A3F?
Oh, yeah.
Oh,
Oh, that's an Amphenol part number.
it's funny because I've
noise.
always
It's kind of like the video person equivalent of not liking HDMI versus SDI, because SDI will lock in place and HDMI always yanks out at the time when you don't want it to. So, Brian.
The other big advantage to XLR for audio applications is that the ground pin connects first. Pin 1 connects first, and then the other 2 contacts make a contact if the connector is set up correctly, as opposed to a jack or an RCA or whatever, where the signal connects first and then the shield connects, and it tends to lead to more popping and stuff.
There are
It
some
shorts
good
during
RCAs.
insertion.
Yes,
Phone plugs short during insertion too, which can be bad.
but there are some good RCAs that have a longer part that the ground hits first. The ground is longer than and it pushes back as you push them in. Specialty plugs.
One of the reasons that we don't like 1/4 inch and mini plugs is because the actual contact area of the connectors, the electrical contact area is super small. You have a round barrel and then a flat spring-loaded contact in the jack. And if you think about that, that's a really small contact area, and all of your electricity is flowing through that small contact area on that spring-loaded flat piece of metal. With an XLR connector and also with an RCA connector, the entire circumference of the pin of the male pin is in contact with the female jack. So you have a lot more surface area where electricity can flow through it.
Right. Yeah. So more surface area. It's a better overall connector, more robust. So all of these things. Now, I mentioned comms earlier, and nobody really kind of picked up on that. How, when you use XLR cable for wiring belt packs and other sorts of comms, and yeah, maybe Justin can take this. What do you need to know? What's different about when you're using it as comms versus when you're using an XLR cable as a microphone cable?
That's a multi-answer question. Depending what you're doing, I mean, you can, on the headset side, wire the headsets any number of ways, stereo or mono. On the line side, if you're doing ClearComm, it's one wiring standard. And if you're doing RTS, ClearComm is a ground wire. I'm very careful about how I'm going to use that word tonight. A ground wire, a plus 30 volt supply, and an audio wire. In RTS, you're going to have a ground, a channel 1 audio and 30 volt, and a channel 2 audio and 30 volt, and a 10 dB difference between the two and different signaling mechanisms. So if you plug them together, you'll get some function, but some unexpected behavior if you're not used to them. And, you know, again, as has been alluded to, there's other systems that are digital party line, through Riedel or ClearComm, notably. I think RTS has one out too that also use XLR for interconnect. So again, it's network speak. It's a layer 1 connection path, and it can be used for any number of things.
Right, but I guess important to note that there's typically voltage applied when you're using them to connecting from a comm power supply and comm belt packs in between, which is much higher than what you would see if you were doing mic or line level through an XLR cable.
Well, I mean, typically ClearComm or RTS is 30 volts and your Phantom is going to be 48, but
that's true.
They show up on different pins, which can, on some consoles, I've seen the magic smoke get out because they weren't expecting to see it pinned the way it was with ClearComm.
And that
can
leads
heat up a transformer too, or a
Yeah.
DI box and also it's duplex, 2-wire is duplex, right? You got signal
Yes.
traveling in both directions.
Which is why you generally see the signal flow reversed when you're wiring comms, so that you can't easily plug a microphone into the end of a comms line.
It's also in this facility I'm in here, we make a point we don't bring comm into the patch bay, so you can't just throw a patch bay across it. You have to bring a comm line into a dry line and make a conscious decision to do it.
right, which you know brings up the point. Just because it fits doesn't mean it's supposed to be connected together. That's an important lesson. And as Justin mentioned, the magic smoke sometimes can come out if you plug the wrong things in where they're not supposed to go.
Well, I mean, this beast is a Sockapex 9-pin. It gets used sometimes for speaker cables. This particular breakout I'm holding has stage pin plugs. So this can show up with 110 volts on it, or it can show up with speaker signals on it. And all you got to do is get wrong which one you're using, and things get exciting fast.
That's right. Yeah, I believe at the facility you're at, for the cinema system, the hangs are done. The speaker cabling to the main 3 hangs are done with the Socko cable.
And I very specifically spec'd it to have the gender reverse, so you couldn't do anything too interesting.
I've seen lighting cables sharing grounds and things like that. People having to make sure that they don't use them for speaker lines.
If we, at the risk sidetracking war stories, I dealt with a shop and a DJ company that put household receptacles on their amp racks and just male household extension cord Edison plugs on their speakers, and just used wheeled trash cans full of extension cords to plug things together. Great way to get interesting.
Yeah.
Wow.
Now, Marty mentioned multi-pin XLR earlier, and since we were talking about comms a second ago, typically, as Justin, you mentioned, you could have mono comm headsets or stereo comm headsets. Those are going to need to use something more than just a 3-pin XLR, correct?
Right. I mean, Well, and again, nobody can decide. There are some systems that are set up. Clearcom usually has 4-pin male off the belt pack. RTS by default is, I believe, 5-pin female. Some folks, if you're going to stereo headsets, you're going to be 6-pin male or female. So it's a real grab bag of standards in comm world.
Yep. And then if you're using like 2-channel belt packs, for example, you might have a 6-pin XLR to be able to run those 2 channels on from one single cable.
Clearcom world, yes. RTS, you get 2 on one 3-pin XLR.
Copy that. Cool. So I think arguably XLR is probably the most common in pro audio that we would see as a connector, correct?
I wouldn't even argue it. I'd simply take it as a statement. I don't think there's a lot arguing.
Right. So how do you guys feel when someone says, hey, grab me that XLR cable? Is there anything inherently wrong in that statement?
I'll jump in just because no. And I mean, I kind of know where you're going because the XLR is the connector. It's not the cable. It's possible for that connector to have different pinouts on it. It's possible for that wire to be different. But at this point, especially on a show site or kind of a common place where we would be doing production, the overwhelming majority of XLR cables are going to be 3-pin shielded to conductor cables. About the only real difference is when you start mixing it up with the lighting people and you end up with some 3-pin DMX cable, which will look physically very similar, if not identical, to a microphone cable. But typically on a show site, while XLR cable is not correct, it's such a common usage that it's pretty clear generally what someone's asking about.
And Brian, since you brought up microphone cable, that actually would probably be the lesser correct as a descriptor, unless you're only plugging in a microphone with it.
Exactly. A lot of people think that XLR is for microphones and then line level things have to be a 1/4-inch connector or have to be some other connector. I've talked to people who were convinced that a line level signal would be too hot for a mic cable to handle. And that's not how this works. That's not how any of this works.
Right. So in that kind of vein, what are some of the accepted that you guys would accept as a term for an XLR cable on a show site, and you know exactly what someone's talking about? We said XLR or mic cable. What are some of these interchangeable words that people use to describe the same thing? Because that could get confusing for someone who's just starting.
Canon, people say Canon cable.
Yeah. I also think Brian sort of hit it, is if you say XLR, people assume it's a 3-pin shielded by default. And if somebody says, I need a DMX, I need an RFU cable or a DC power jump, that's going to be differentiated. I think if somebody says, grab me an XLR, it's assumed 3-pin shielded unless otherwise specified.
Yeah, I would ask for a 6-pin, a 6-pin cable or a 6-pin XLR or a 4-pin or power XLR.
And every cable trunk I've ever seen labeled says XLR on it, XLR cable on it of various lengths.
It says XLR? That would be redundant.
The trunk says it,
Oh.
Speaks.
Written on the trunk.
Yep.
Or on the Cadillac.
Copy that. Yeah, no, exactly. So but people might refer to it, as we said, as mic cable or something different, but those are essentially, they're referring to the same thing, and we would assume that. Cool. So I think we covered XLR pretty well. Omar, are there any questions so far on what we've been talking about?
Yeah, so I got one question for you guys. It's a little bit off of, it still falls in line with his cables, but it's a little bit off the topic here. But I'm gonna ask it anyways. So the first question we got was from Mike, and he says, "Hey guys, when using a Behringer UMC44 HD call audio interface that is connected to a vMix laptop, what kind of cable would I use to output audio from the interface to the speakers in a meeting room to share vMix caller audio?" So we're still kind of talking cables here. I know this goes a little bit over what we're discussing, but pretty much, what would I use to playback port or on the audio interface for the output instead of the main output? That's the first question we got from Mike right now. It's a
So
lot to digest. I know.
yeah, I'm not familiar with that Behringer unit. All audio interface. Yeah, I think this is kind of super specific, and I don't know the piece of gear unless anybody knows it off the top of their head. Brian?
I just looked it up. It's got XLR connectors on the back as far as its primary output. So the most preferable thing to use is always going to be an XLR. If a device has an XLR output, that's your first choice. It locks, it grounds correctly. It's nearly always balanced. So it's pretty close to a sure thing. So I would say if you're taking that to another XLR equipped device, then a mic cable, as we talked about before, an XLR cable would be appropriate.
Should we mention that maybe it's also kind of standard thinking that given the choice between a balanced and an unbalanced output, the balanced is superior because it will reject noise, and it'll go a long distance without noise. Even a balanced TRS is still better than an unbalanced TRS. So
Depending on what it's
Provided you're
going
going
into.
into a balanced input, yes.
correct. I mean, you want to match protocol at both ends of whatever you do.
Right.
you know,
So a lot of
or
interfaces
convert.
have both XLR outputs and quarter-inch outputs that serve different purposes. Like the XLR would be the main outputs, and quarter-inch might be bus outputs or something else like that. And if you were going to like loudspeakers and a laptop, for instance, you would take your XLRs to your power amplifiers, and the quarter-inch might go to your laptop, but you want to be sure whether those quarter-inch outputs are balanced or unbalanced, because your laptop may be unbalanced inputs and you don't want to mix them up. You've got to convert them properly.
You know what? Since we're talking about it, maybe Justin, do you want to walk us through, and maybe Brian can also help interject and talk
Yeah.
about the difference between balanced and unbalanced?
Give me a second to pull a slide, which is horribly out of order, so I may be a little awkward here for a second.
Sure, no problem. And if you guys have questions, make sure you get them in. Now would be a good time. And otherwise, we're going to just keep rambling on about cables. But we want to make sure that we get to the questions that you guys have for us. So go ahead, Justin.
Okay, balanced and unbalanced. I'm trying not to do, I'm half tempted to do the full lecture here. I don't know if Brian or everyone wants to jump in. There's basically two ways you can get noise into a system, and balanced versus unbalanced is about both controlling noise and distance you can run. When we say balanced, I'm debating which way to start here. If you get noise into a system, there's two ways you can get it. It's either what they call differential mode, where it's coming in as part of the circular circuit, or common mode, where it's coming in on the inputs. Yes, I just simplified that a little. So the two ways to do it, there's a couple ways you can reject it. Twisted pair we use a lot to, well, let me do balance first. Unbalanced, you have what we call a driven ground, which means the signal is, you're both putting the signal across your signal wire, and you're also referencing it, bonding it with the signal ground. And the problem there is anything that your signal picks up separate from your ground is going to be imposed on the signal and come out with the signal. The inherent problem there being you will never have the same resistance in your signal path, your ground path, and anytime there's a difference in resistance, there's a potential for, it'll create a voltage potential, which makes a way for noise to get in. And when I get to the other slide, I'll show you the other problem with unbalanced. So when you're doing balanced, you hear a lot thrown around, oh, balanced means it's 3 wires. The definition of balanced is you're carrying it on two conductors which have an equal impedance with reference to ground, which basically means in a practical sense, their polarity is reversed. So where the signal is rising, it's the same signal, copy both ways. Where the signal is rising on one line, it's going the other way on the other. So what you end up with is the same signal imposed on both lines, the same noise imposed on both lines, but the signal is reversed. So what happens when you get to the input is the input, either through a transformer or active balancing, it reverses these lines and combines them. So when that happens, you get both signals add and reinforce each other, and the noise get flipped and it cancels each other out. So what you end up with is actually 6 dB more signal, and it cancels the noise out, which helps you a lot. And the other thing that happens, so you can do it either actively or with the balancing transformer. The other problem with unbalanced lines, and sneak preview we'll talk about filtering next week, is, and I believe Jason will talk a bit about coax cable a little later, is that if you put a resistor, i.e. a piece of wire with a capacitor across it, i.e. a coaxial cable, you make a low pass filter, which causes you to lose high frequencies. And the longer the cable goes, the higher the resistance, the more it rolls off. That's why things like, the tone control on a guitar amp is basically just making a low pass filter and turning it down. Well, the longer your unbalanced cable gets, the more you start to lose high frequencies. And once you get past about 15, 20 feet, it starts eating into your usable audio range, which becomes a problem. So that's the 10,000 foot view. Anybody have anything they want to add? I'll throw one more bit of trivia in before I jump out, which is what happens here. This is the things to talk about next week. This thing of taking two signals and adding them inverted and canceling them out. For the old time trivia, it's also how FM radio works. You think, okay, you send a left channel and a right channel. You don't. You send one signal is left plus right, which will work with mono, and the other is left minus right. So you can either get mono or you can combine together out of phase and you get double strength right and double strength left, which is cute trivia, except as far as the FCC cares, your in-ear monitor systems, with the exception output power, are miniature FM radio stations. So when we're using in-ears, you have the exact same thing. You're transmitting sum and difference and combining them. And because you have to have a pilot tone, that both affects how much stereo spread you can get and how high your frequency response can go. So that's just a preview to next week. So
Cool. Thanks, Justin. So anybody else have anything to add to that?
There's a difference between a tip ring sleeve 1/4 inch or mini plug, and how it's used can be a mono balanced signal or stereo unbalanced signal. If we take a look at the chart here again, we'll take a look and you see this is a tip ring sleeve 1/4 inch connector. This can plug into the stereo output of a keyboard or a headphone output on a mixer. Same exact plug, same exact pin out, but they're used completely differently. If it's a mono balanced signal, the tip and ring are positive and negative, just like Justin showed. Same thing on an XLR connector, but in a stereo mode, the tip would be left channel, the ring would be right channel, and the shield is ground. And you really can't mix these up. If you were to take the stereo output of a keyboard, convert it to an XLR connector and plug it into a microphone input, what you will hear is a very strange signal that would include no audio information that was centered between left and right. because it would cancel out. The only thing you would hear if the keyboard was in stereo mode was any audio that was extreme left or extreme right because of that cancellation. And if you were to take a mono output and plug it into a stereo input, it would also not work.
So that actually, ties into, we did yesterday on our Discord channel, we did a session on ATEM Mini audio and how the audio inputs work on the ATEM Minis. And that is exactly the reason why some people have so much trouble using them, because the ATEM Minis are a unbalanced stereo input on an 1/8 inch TRS connector. So in reality, and we did about an hour and a half on that yesterday. We're going to work on maybe cutting up some of the recording that we got to make some smaller bites for you guys. But essentially, what we discovered, or what we demonstrated yesterday, was that with those ATEM Minis, because it is each input, there's two of them, they're unbalanced stereo inputs on a TRS, you actually get 4 channels of audio between the two inputs, 2 channels per pair. So you can have 2 microphones plugged into one input, or you can have a stereo line level input if you switch in the software to line level. And it's a very problematic if you just grab a cable from Amazon that's a single XLR to a TRS 1/8 inch little mini cable and plug in the mic, and all of a sudden you don't hear what you're expecting to hear. We actually even demonstrated a full phase cancellation if you did something like that by listening to it and whatnot. So really cool talk. We'll try to get that up for you guys. But the best way to get some of that exclusive content is make sure you join our Discord. We'll get a link up in the chats for you momentarily. But yeah, no, very, very good, Marty. Thank you for pointing that part out.
Just to throw one more wrinkle in there, something that got touched on last week, is you can also see tip ring sleeves plugs used as inserts on mixing consoles, where you'll get unbalanced in and out, where typically signal comes out of the console on the tip and returns on the ring with a common sleeve, which can make a real confusing mess.
And since you brought it up, I actually went out and grabbed a couple of old insert cables, other than the ones that are in the rack that's living under my console that's still set up from last week. But these two happen to be loomed together. But this is exactly what you would get. Is on one end, you would get a TRS connector where you have the tip, the ring, and the sleeve. Try to focus that a little better. Want to. And then on the other end, you get 2 single TS connectors. These ones happen to be labeled tip and ring. So depending on how your console is sending that signal from the insert, somewhat standard is to do your send on the tip and your ring as your return. So that means going out of your console is on the tip, and then coming back to your console is on the ring. That's somewhat standard. So that's how that cable would be used in exactly that situation. So thanks for giving me the opportunity to do some show and tell, Justin. And now that it's begun, I'm sure we may start pulling out different cables to show. But great. Let's see. One thing that we talked about briefly was shielding. Well, hold on. Let me look at other connectors first. And is there any questions? Are there any questions yet, Omar, that we need to address before I?
Yeah, so I got 2 questions here for you.
Sure.
As I say that, I am trying to color one of these because it is white on white. Here we go. So the first one is from Leland Best, and he's asking, does a twisted pair create a loss of dB gain on the signal? And I'll give that to Brian.
No, the twisting alone won't result in any sort of signal loss. The primary thing that the twisting does, and there's lots of secondary effects, but the primary thing is that it makes both conductors see, for lack of a better word, the same amount of interference. So it's the same amount of noise ends up on both of the wires. And then when it gets to its destination, the differential amplifier on that end can then basically take that signal and go, these two things are exactly the same. I'm going to cancel those out. Anything that's different, I'm going to amplify. But the twists in and of themselves are not gonna aren't gonna cause any signal loss. And a lot of times think of a twisted pair is thought of as adding distance, but what, you know, like, oh, with the twisted pair you can run so much farther. But what it really is that it's so much easier to cancel the noise out when it gets to the other end, that the signal that's left is much easier to interpret. And that's even digital signals. Cat5 cables, for instance, use twisted pairs largely for noise reduction, amongst other things.
And it should be noted that this is all at audio frequencies. Once you get up into radio frequencies, things behave very differently. And twisted pairs tend to attenuate rapidly over distance at higher frequencies.
Anybody want to talk about the advantage or disadvantage of star quads?
I have that on,
and disadvantages.
I have that on the list when we get to kind of the cable portion. But before we move away from the TRS and the TRRS, that's what we didn't talk about, was the TRRS. So what you have on your common headphone or headset jack, you know, this is just a standard, you know, kind of earbud thing. We've got the TRRS connector. There's a tip and 2 rings and a sleeve. So that's a little bit of a different ball game, because in this headset, it's carrying a left and right audio plus the microphone audio. So audio is kind of going in both directions. So when you plug it into something like your phone or your computer, if it has an 1/8 inch jack on it, or an iPad, that's how you can do those communications. And it's not wired the way, there's been a couple standards. Is anybody familiar with some of the ways that these get wired in our common iPhones, that's when they still had jacks, you know, inputs, and Android phones and things like that?
And some of them can be a video output too, instead of microphone. Little camcorders. So they have the TRRS, where one of the
right, they called
the
them
microphone connectors actually a video output.
the
Opposite
AV
video.
plug, as they used to call it, right?
Right.
But in typical phone usage, we have, just like you would on a pair of headphones, your tip will typically be your left channel, your first ring will be the right channel. Then the common standard that I've seen, and if anybody else is seeing something different, let me know, is that shield is the next one, and then the closest one to the base of the connector is actually the microphone. That wasn't always the case, and this has been a, you know, it's.
You know why they do it that way?
Why is that?
So it's short. So if you're using a headphone jack, it shorts the microphone connection to ground. If you don't have a microphone, then the microphone input on your computer is shorted to ground and shut off.
There you go. I didn't know the answer to that. I just knew that they changed the you know, the way they do it, and that's why it used to be. I mean, now it's not a big deal because iPhones don't have the headphone jacks, but for a while you would see headsets that were labeled that they worked for iPhone or they worked for Android, because it was a different way that they actually had those wired on the phones. So
Yeah, there are actually 2 different standards. One is called the OMTP standard. The other is a CTIA standard. They're here on the chart. I put a link to this chart on the chat. The OMTP standard is older, was used by Nokia, Lumina, Samsung, Chromebooks, and older Sonys. The newer one is the CTIA and AHJ standard, which is used nearly everywhere. And since 2013, and it's where tip is left, ring 1 is right, ring 2 is ground, and the sleeve is microphone. Although there can be exceptions to this, so there is no definitive standard that's universal.
There's another consumer standard for TRRS as well, and that's they call balanced headphone, where tip is left minus, ring 1 is left plus, ring 2 is right plus, and then shield is right minus. I have one right here that when you used a what they call a balanced headphone amplifier, that's the standard.
Cool. I wasn't aware of that one either. So that's
It's
why
a hi-fi thing, hi-fi esoteric, expensive stuff type thing.
That's why I invite people smarter than me to join us. Cool. So unless there's anyone else that wants to add anything, the one thing maybe that's worth mentioning, I guess, grab an example, just because we were talking about 1/4 inch versus 1/8 inch, and the size difference. Obviously, one is bigger than the other. This is just a guitar cable, a TS, so it's only got tip and sleeve. This is that TRRS I was showing you, but this is a 1/4 inch, this is the 1/8 inch, and it's referring to the diameter of the physical connector. For our people, any of our viewers who are in countries that use the metric system, that would be a 3.5 millimeter is the 1/4 inch, and then a 2.5 millimeter is the 1/8 inch. Is that correct? Or am I saying that wrong?
3.5 is the small one.
Right, 3.5 is the small, and then what's the large ones? I'm not, obviously I don't know
6.
metric.
6 millimeter.
6 or 6.5. Yeah, 6.
And there was a 2.5. It's like the
Yeah,
My
3/32
balanced headphone.
Right, it is. Yeah.
My balanced headphone is 2.5, actually.
yeah. I had one piece of gear once that had a 2.5 millimeter.
Now there's another kind of connector that looks almost like a 1/4 inch connector that's used for patch bays, but it's shaped differently.
Yep. I think
Justin has one of those.
Justin has one. Let's take a look at that.
But just want to jump in here, guys, real quick. Darren from Ireland is saying it is 6.3 millimeter. is what
Oh,
it's
thank
called.
you. Perfect. So Justin, you want to tell us what that is that you got in your hand? Oh, you're muted.
Muted.
Come on, I only got so many hands to work with here. This is a long frame, which is, you can actually badly interchange them with 1/4 inches in patch bays, but this is used for lower density or higher powered patch bays. We actually have a few around here that use them for a low powered speaker patch. So yeah, it's a variation of the 1/4 inch. This actually originated from telephone world.
But you can see that the tip is shaped very differently than the bulbous 1/4 inch connector.
And then
And here's a TT or a Bantam patch cord by comparison, which are used more in like 96-point patch bays to give you double the density.
You can fit a 1/4 inch jack into a long frame, but you'll
Yeah.
destroy the long frame
Correct.
eventually by doing that.
And just to completely, let me see if I can do this without losing it. But yeah, to completely traumatize the panelists, there's the stereo Bantam jack, which these are horrible because like most of these jacks, you need to give them that magic little twist to stop the noise from the oxidization. And you can't do that with stereo ones. Save cables, but they make a lot of noise.
And it's also worth pointing out that there are some patch bays that are built specifically for 1/4 inch, standard 1/4 inch connectors. And so you got to know what you're working with.
correct. Cool. So we're just in the interest of time, I want to start kind of moving us along to other connectors. We didn't talk much about the other variation of XLR, like the mini XLRs that you might find on wireless systems. Shure uses often the TA4 series connectors, which are just a smaller connector. I don't have my example of one. I do have one. I have a TA3 and a TA4, and I don't have either of them here. The TA3 is a 3-pin connector, where the TA4 is a 4-pin connector, and that would be the TA3F or M, depending if it's female or male, and vice versa. But if you ever used a wireless belt pack from Shure, typically that's what they come equipped with. and it's just a smaller form factor. The older Beta 91s use the same kind of connector into the little preamps. So they have uses. Justin, correct me if I'm wrong, the PCCs, do the PCCs have the TA3s?
Oh, just to be difficult, the PCCs use the 3s. I think Beta 98s have 3s on the capsules and 4s going into the preamps. I may be wrong on that, though.
That is correct. Same with the 91. 91 is just a 98 in a different case, by the way.
And here's an example of one. in case you're
Hey,
wondering.
there we go.
Let's see if I can hold it. There we go. You can see the connector. And it has the little button on it. Release.
Let me spotlight you there for a second.
Oh, here you go. There you go.
So it's a little different shape, as you can see, and that's the female end. But it's also locking, and they are a pain to repair, I can tell you.
This is on the end of a standard Shure lavalier mic here.
But not the worst wireless connector. There's
No.
much worse ones.
On a Limo.
Limos.
Correct. Limo.
Right. Cool. And then we did mention XLR earlier. I think Jason mentioned the AES EBU. Same connector. The cable is what's different on an AES cable. It's a different resistance, if I'm correct. 75 ohm. Oh, no, sorry, 110, right?
120.
110.
110?
110.
Yeah,
Yes.
110 ohm. Yep. And that's for the digital transmission AES EBU that we were talking about. Cool. So next on my outline, which I sent you guys, all the panelists, if you didn't know what I was working from before, RCA. We've probably all seen these. As we've talked about before, these are an unbalanced connector. And one of the things I think Jason brought up earlier is the point that the signal plugs in before the ground. So that's not always an ideal, kind of
Unless you
connection.
buy
that
the
we like to-
expensive ones. There's an expensive one that's different, but most of them are like that. Yeah.
Yep. These are labeled, you'll often see these with white and red for left and right. You might see yellow, which typically indicates video. Or if you're looking at component video, you might see RG and B, red, green, and blue. None of that matters. The cable is all the same, and the connector is all the same. Some of the uses you see for this are stereos, like home stereo equipment might use RCA. Some speaker may use this. There's also a digital SPDIF can travel over a coax cable using the RCA connector. And as somebody else added to my notes, it can be used in analog video, as I mentioned, either as a composite with the single, usually yellow, or a component, which would be 3 cables carrying the red, green, and blue with sync on the green. Cool. Anybody want to add to anything there? Otherwise, this is kind of a consumer grade cable. Like I said, home stereo, tape decks, things like that might use these. I keep this around for in my tech kit usually, in case I have to. And this happens to on the other end have just a mini TRS plug. So this is a Y cable that I can take like the output of an iPod, an older iPod, obviously, because they don't have these anymore, and then go into something that is RCA inputs or vice versa. And then I usually carry around a couple of these adapters, which are the female RCA, where these click together and turn it into a 1/4 inch. And this just lives in my tech kit for when I need to get something like this into something else that isn't this. So, anyone have anything to add? Otherwise, we'll move on to what's next. Cool.
I got a question in the queue here that I'm not sure is
Sure.
totally relevant. And Ed, I'll let you let me know if this is good or not. So the question is from Steven, and it's saying, how do you control audio latencies during streaming to YouTube? This might be a little too far off topic for what we're doing tonight.
Yeah, that is, and I noticed that we're getting a little bit of a laggy signal today. That has to do with my NDI network. So if that's what that's if that's what's inspired the question, I apologize. But yeah, that's kind of a little far off from what we're talking about tonight. We'll hold on to that though, and if you want, you can go ask that in our Discord, and someone else will pick up on that, or me or Omar or somebody on our team will come back and revisit it.
Perfect. That's kind of what I was hoping would happen there. So my other one here is from Leland Best again, and this one I was trying to get to before you guys switch topic here, so I apologize to go back a second here. But he asked, so those older TRRS cables wouldn't be compatible with the newer connectors? Is the question.
Yeah, I mean, it's a different. If it's following the older standard, yeah, they won't work. And I mean, I remember the struggles, of buying. Or just getting the headset that came with my phone and then plugging it into a different type of phone and it not working and things like that. So yeah, they wouldn't work. The microphone would be shorted to ground, or typically if you had the wrong, as I forget who brought us up to speed on that earlier. I know Marty mentioned it, the standards. So yeah, that just wouldn't work.
And then I got one more for you guys, and then I apologize. I'll let you go forward it. So David Brady's asking, what is the difference in RCA between the split blade ring versus the solid blade ring like you have there? Besides the split, obviously.
Anyone want to take that?
Just a different design. Some of them are split around the outside, and some of them are solid. However they wanted to make them that day.
Yeah, really isn't much of a difference, except that with the split blade ring, if it becomes loose in the jack, you can always squeeze them together a little bit, but you generally don't have to do that with the solid ring.
Right, and either way, if you step on it, you're pretty much going to break it. That's the doesn't matter which type it is. So yeah, that's again not a connector I typically rely on unless there's something where I have no other way to get it in or out. The other thing to note is typically that the RCA is going to be an unbalanced. I think we mentioned that. They can be shielded. They're typically shielded, but they could not be. And like if they were a speaker line, that it's not going to be a shielded cable. It's going to be an unshielded. And what was the other point I was going to make? They're typically used in consumer line level as opposed to pro line level. So that's another thing. Typically you see them at the lower level or carrying speaker loads. So.
And SPDIF too. They get used for digital audio.
Right. Yep. I mentioned that. SPDIF, which is a remind me what SPDIF actually stands for. So I know it's Sony, Panasonic,
Sony, Philips,
or Philips. Okay.
Don't know the rest. Digital format.
Digital interface format.
Digital interface. Yeah.
There you go. Cool. Excellent. So we'll move on. Where I'm going to kind of briefly just show. This actually happens to be an SDI cable, but it uses the same connector, which is called a BNC connector. I don't know if I don't think Marty had that on his diagram.
No,
Oh,
it's
we
not on my
can we can
diagram.
keep playing. Where did that connector name come from?
Sure.
Oh, British
Bayonet
Navy
Neil
connector.
Consulman.
Yep. Prize to Jason, followed by TNC.
We'll touch on BNCs during the coax section.
Yeah, perfect. So I'm not going to go too far into it other than to show I don't have anything MADI. Typically, MADI uses the BNC connector as well as antenna cables. And, Jason's going to go into some of that. But I do have my decimator, which is a BNC connector that the cable will mate to. It goes in. Sorry, I didn't realize I was not going on. Goes in, and you give it a little twist, and then it is a locked connector. There are also BNC barrels for when you need to connect two cables together, though I don't typically like to do that, but you can connect them together. And just for fun, for some of you guys who probably have one of these in your tech kit somewhere or used to, and any video people who may have worked on RGB HV, I have a trumpeter tool, which if you're working in a real tight space, you can, of course, this SDI cable is too fat of a jacket to get this one on, which I should have probably tested that before I did it. So this will be useless, but this would go in there, grab this collar so that you can get that twist, because if you have fat sausage fingers like I do, it's very hard to get into some of the tight places that these connectors find themselves. And then, yeah, just Jason, when we get to your thing, I'm sure you're going to talk a little bit about coax cable and some of these connectors. Cool. Moving on, and then I think we're going to maybe, Justin, if you just briefly show a couple of the examples of multi-pins that you have.
Yeah, stall for me.
Sure. So multi-pin connectors help us out, especially in the live sound world where you have to make a ton of connections. You can, it puts a ton of pins, as we talked about earlier, into a single connector that mates with a female connector that has a ton of, what are we calling pins and sockets that they mate to, and you can get a ton of connections in a smaller space. Whirlwind makes some, Ramlatch makes them. There's EDAC makes Elco.
I'm suitably stalled if you want.
Okay, great. So Justin will lead us through this.
There's a bunch of them. There's a ridiculous number of them. I got ahead of myself. Some have kind of atrophied over time. I think we were talking about this pre-show today. I think some of them trigger some of us who've been around a little too long. So I just want to hit some of the more common ones. I have physical examples here, but I may have to come back to them because I want to drop in and out of screen sharing. The first one is the trusty EDAC Elco, which used to be used a lot for interconnects. I have one here, which is going to be impossible to see in green screen. The thing that was most distinctive about these is they use a very unusual contact, in that the contact is what they call, Ed talked about the male-female terminology. They use the term hermaphroditic because if you look, the two contacts that are used in either the plug or receptacle side are actually identical. They just get turned 90 degrees, so they mate, which is actually a pretty good thing for the design, because the way they fit together, they don't tend to bend too easily. And because of the way they fork together, they actually have 4 contact points under spring tension, which actually tends to make a pretty consistent contact. One thing worth saying at the outset when we're talking about all these different multi-pins is that they tend to have, each has some pluses, each has some fatal flaws. One of the big fatal flaws with most of these is if they jam when they're mated, they're all but impossible to get apart because there's always something on the face you need to get at them. So one of the great failings of the EDAC plug is that there's actually a little nut that locks them in, and if you cross thread the pin that holds them together, I'll look at more once we're out of slides. If you cross thread the pin or the nut wears out enough that it spins, they're all but impossible to open. Next up, for those, I don't have one physically with me, but anybody who works on a sports TV truck will know these. The DT12 connector, 12 channels of balanced audio. I just put a rack panel there with a picture of one for scale and size. Pretty darn durable. They take a lot of abuse, and the wiring and the presence is pretty standard across TV trucks. So you'll pretty much find them anywhere, and they make, if you got a cross connect, pretty easy. Whirlwind, the Mass Series stuff, has its good points, has its bad points. Something that's worth saying is any of these connections, they all come with dust caps. They're worth keeping on them, not just because they keep the dust out, but because they keep them from being physically damaged. This is especially true of Whirlwind. The series is W1 through W6. We'll hit on all of them briefly. The W1s and W2s are sort of a mil-spec style connector. They're solder only. When they break, you're in for a really bad day. Repairing these is no fun. A couple tips if you're using these. Always keep the caps on them, because the two things that will break are the shell here gets bent, or one of the pins gets bent. The other thing that goes bad is these nice Kellams grips are great and they hold the cable really tight, but they also tend to twist when the cable twists, and then it breaks the wires inside. So if you're using them, keep the dust caps on them and deal with the pain in the shop. Take the set screws out, back the strain relief off, and put a little Loctite glue on them. It'll save you a lot of pain in the field. Not much fun.
It's also worth mentioning too, Justin, when you mate these, that they're keyed, right? The way they connect.
They are keyed, and they've got studs around the edge to make them connect. If you get somebody who's a little more gung-ho than thinking type, you can line these sleeves up off place with the studs and crank them hard enough that it'll sort of engage and destroy everything and make a mess. So yes, look carefully at the keying, because both the keyways and the locking studs are slightly offset and you can get in trouble. Now, next thing we'll see about Whirlwind, W1 is 12 pair, W2 is 20 pair. Now it gets screwy. The W3 through W6s are a very different design. The cables are, they like to call them hermaphroditic too, in that the cable is half pins and half sockets. These use the exact same pins as your typical D-sub style computer connectors, which is bad news because they're really fragile. Because they're half and half, you can splice the cables together and use it as extensions, but the input and output are different wiring. I can tell you, if at like 3 a.m. on like some fashion show loading, you suddenly think it's a cute idea to just put a whip on each end of the trunk rather than put a box and a bunch of jumpers. It doesn't work, and your popularity rating with the crew goes down real fast. So yeah, most of these you find, because of the way those rubber sleeves mate, they're pretty weather tight, but if you wiggle it wrong, you're going to bend pins and you're going to have a bad day. The odds you're straightening a pin without breaking it real low. If you break a pin in the socket, bad day. So if you're going to use these, thread the collars all the way back, gently mate them, then thread the collars on. Also notice Whirlwind's numbering scheme goes to hell fast here, because the W1's 12, the W2 is 20, the W3 is 40 pairs, the W4 is 56, the W5 is 16, the W6 is 28. No rhyme or reason, it's just the order they came up with them on. Also, these things have dust caps. They're valuable. Make sure to put them on, but the caps and the sleeves are aluminum, and if you don't put a light little bit of lubrication on them once in a while, they will gall and seize. This one is not a gag photo. This is our intrepid host and another co-worker of ours on a show with a W6 where the end cap seized, and we needed that cable for the show. This is no joke. It took 2 guys with pipe wrenches to get the end cap off. So a little lubricant on the thread will go a long way. Oh, now I'm out of that. So let me get out of this.
That picture is actually proof that I do work. It's amazing.
It is, wearing gloves too.
Always.
So,
I don't want to ruin my hand modeling career.
Yeah. So this is the actual EDAC plug. They come in a bunch of sizes. This is medium one. I forget. I think this was like a 12 pair. Just because it triggered a bunch of the veterans here. These are what we call G-block. These were standard. Thing about these, they use the same 23-pin block, and you can get them with either 1, 2, or 3 blocks. One of the things to watch out with these, aside from the skinned knuckles, is that there are 2 wiring standards for them. If you do the fast math, 3 times 23, that's 69. That doesn't divide well by 27 pairs. So there's a high count scheme that uses shared grounds and a low count scheme that does not, and they don't mix and match well. This is an actual W2, which the cover's a little seized on. Gotta practice what I preach about lubing the covers, but same thing. It's pins and sockets. The one I didn't put pictures of in the slideshow, and of all of the fatal flawed connectors, the one I probably get along with best at this point is Ram Latch, which is 54 pair. This actually uses exactly the same pins as G-blocks, so you can pin for pin each one. I like these. They're nice. They're rugged. They're relatively fast to build, too. I mean, the first time I did 54 pins of this, it took me about 4 hours out of the gate. Same tooling. The only real downside to these in my book is that they're really big. If you take
They won't go through a pipe. You can't pull them through a pipe in a theater.
Through a pipe, and this is a fan out. Stuffing one of these in the doghouse on an LS9 ain't gonna happen. So
It's also easy to push. If they get old, the pins are easy to push in, and they're problematic that way. You got to be super, like a lot of these ones.
you know,
You got to be
it's
super careful putting them in gently and making sure everything's sitting nicely. You can't be quick with any of these things. And you can't throw that thing on the floor; it'll smash into pieces.
It's actually, I've found the Ram Latch is pretty durable. There's also interesting conventions on sockets and pins. The G3 is, pin output, socket in. The Ram Latch is by convention, pins on cables, sockets on panels. And I say that because I knew somebody, apropos to Andrew's comment, who, because they came from G3 or G blocks, set everything up ins and outs. So some of their cables had pins, some had sockets. So when you were pinning their racks, you could not pay attention and put a plug with sockets to a panel with sockets, and it didn't work very well. They could also, if you weren't paying attention, try to put pins to pins. And there was actually a show where a local hand was being helpful and put things together, came up to the system tech and went, boy, that one plug needs some attention. I had to really hammer on it to get it in. Because, he had put pins to pin and hammered on the handle till they bent and drove past each other. Amazingly enough, after enough force to get the thing open, it went back into a socket and worked fine. So it took the abuse pretty well, although the new Ram Latch shells do better. The old amp ones they were based on tended to break more.
There's one thing the Ram Latch does that I don't know of any other multi-pin that does, which is when you can seat it in the connector, disengage the latch, and it won't make any connections. So if you've got a band on the other side of the stage that's going on second, and they're on that sub snake, you can release the main snake, one sub snake, and push the other one in, or just engage the latch, and you're done. It takes 5 seconds, if that.
That's one of the things I like, because if I'm in a festival situation, we'll do that. We'll just line up multiple Ram Latch stage boxes for openers, for headliners, and just bang the trucks across as we need them. Of all the multi-pins, the Ram Latch is probably my favorite, and I don't know if I would say I hate mass, but it's darn close.
Well, Justin, thank you for going through that, the comparison of different multi-pin connectors. If anyone's in the touring world who's watching, you've definitely seen some sort of multi-pin connector on your snakes, which just the term snake, if anyone who isn't familiar, it's just a bunch of channels of cable inside of one massive cable. So you can, and usually we call it, as Justin mentioned, 56 pair earlier. So that's as we were talking about XLR. we have 2 pairs of cable plus a ground. So if you have 56 pair, that's going to be 56 channels. So that's 2 conductors per channel plus a ground. So it's a lot of cables. So when he says he built his first 56 pair in 4 hours, that's 56 points times 3, the hot, cold, and ground that he had to populate inside that connector. So, definitely, it's definitely I've built a couple of those RAM latches too, and it does take a little bit of time. I've built some Elcos. This console behind me in my background was 23 16 pair Elco connectors. So 16 channel Elco connectors, which actually it has a couple extra, there's unused pins in them, but yeah, to get the 16 channels. But yeah, I taught a couple interns from the local college that Justin works at to populate those and build them and terminate XLRs. Not a fun project, but very time consuming. We didn't mention anything about DB9 and DB25s, and I forgot to grab I have an example of a couple that were wired for using the old Tascam wiring scheme, but I don't have them with me.
Mickey's holding one
Looks
up.
like Mickey has one. Let me get Mickey spotlighted real quick. Mickey, thanks for joining us. Appreciate you hopping in. That looks like a DB25.
Yes. Yeah, I was wondering how common is DB25, at least in the live environment. I know in studio hardware, it's pretty much a standard in terms of multi-channel connectors, but is it common in live?
Not so much. Not that I encounter very often. But I have an old multi-track recorder that that's what it was using. It was using DB25s to take 8 channels of audio in. And then Justin, what did we build with the ClearComs? Those were DB9s, right? That we were putting together.
Oh, we were doing radio breakouts with the Unity interfaces.
No,
But, I mean,
the ones in the SM consoles. The
oh yeah, off the ClearCom rack stations, the DB15 breakouts.
yeah, DB15. So
I mean, you'll see things like the Yamaha cards or the RedNet interfaces that use them as breakouts for AES or analog.
Yep. So, well, Mickey, I'm glad that you jumped in and you had that example right at hand. Of course, Mickey has everything right at hand. That's a great job. Thanks, man. But yeah, again, just a way to get multiple channels of audio into a much smaller space. And so you have to make less connections, saves you some time. And you can leave these things, as Mickey mentioned in a studio situation, you can leave these things plugged in all the time. And they're locking typically. I'd love to move on because I'm looking at the time. Omar, if you have more questions, we can take a couple questions.
Yeah, so I got one, and I'll give this to. My screen just went away. Always, right when you need it. Anyways, yeah. So I got one from Frank Henney. Do you use an XLR cable tester, and if so, what's a recommended one? And as soon as I did that, so Marty, I'll let you take the lead on that one.
Yeah, let's see. So there are a bunch of them out there. There's one I really like. I don't have it handy on my wall here. Let me see if I can find it for you. Let me get back to you just a minute.
All right. So while you look for that, I'll let Ed go, and he's got something in his hand right now.
This is one of the ones I use. It's modeled after I think Whirlwind used to make one that was like this, the bug catcher. So it'll do, a handful of different types of cables on the input side and on the output side. Actually, of course, I just showed you those backwards. And that's just, of course, the green light turn ruins my key there. But you can plug something in on one end. And, this was a relatively inexpensive one. And the way this one happens to work is I can see this is telling me that pin 1 on the input and output are matched. Or of course, it's going to key out the green lights. Pin 2 and pin 3. There's nothing on pins 4 and 5, but if this was, there's 5-pin DIN on here, which is used for MIDI. So I'd be able to test those. I can also test NL4 connectors, which are speaker cables, which we're going to start talking about in just a moment. And then somebody was going to talk about their Q box. Wait, hold on. Before we get there, Leo's holding up his. Let me get to Leo real quick.
Yeah, it's pretty cheap, the Behringer tester, which I carry around. It covers most cables that you run in the sort of the non-studio environment or non-production environment. The only thing with this is it has a really annoying habit of every time you get it out, you find that the battery is flat. So I have to tape over the on-off switch. Otherwise, you just find every single time the battery is flat.
One of the greatest features about the cheap Behringer one, it's a little different than that one, is the intermittent mode. That's the most useful function I've ever seen on any tester, where you can plug it in and it tells you if there's been an intermittent
This is
connection. You
intermittent.
shake the cable and then you can see if you've got any intermittent connections.
This
really,
has it. So this
it
is the
does it
one
well.
up from the
I haven't
cheap
seen
one.
that one.
This
That
is
looks
the
great.
one up, but it's
It's a great feature.
It wasn't that much more. I mean, it does do network connections as well, so it
Oh.
has most things for in there.
We'll go to
Mickey's
show-
got one
That's
that I've
the one.
seen actually.
Marty's got one.
Yep,
Sorry,
go ahead,
I'm on Marty.
So this is called it's
I'll go to
a bit
Mickey
of an
next.
older design, but it's one of my favorite testers. It's called the Swiss Army by Ebtech, EBTECH. It does 1/4-inch XLRs, mini plugs, RCAs, DIN connectors, and Bantam patch panels. And what's
And that's
cool
the
about
one that
this is
Behringer stole.
this is the one that Behringer stole, exactly. It's got this matrix of LEDs here that shows you how each pin is connected from each end to the other end. So if it's wired correctly, you'll get tip to tip and ring to ring and sleeve to sleeve. But if it's miswired, it'll show you exactly which ones are miswired. And when you move the connectors around, if there's any intermittence, one of these three LEDs up here will pop up to show you which wire is intermittent. This can also connect test a wire from one end. So you plug one end in and you go to the other end and you short out all the pins. And if they all come up properly, you'll know that you have continuity on all of the conductors, which is really cool if you're testing an in-wall wire, because you can't obviously bring the other end of the wire to the connector, so you just need to test it from one end.
Does anybody have one of the rat sniffers? Do you have that?
Not
do you have
on
that
me.
Oh.
I do have it, but I don't have here.
And then Mickey, what was the one that you had in your hand a second ago?
So this one is a one from HOSA. I've seen a bunch of manufacturers with exactly the same box, so I don't know if they're just rebranding it, but it has a
The
speaker,
Core Audio is just
has-
like that too, yeah.
has Ethernet, has a bunch of the standard connectors on one
Is that-
side and another set of connectors on the other.
Was that
And
NL8
it
on the
looks-
top?
Yeah.
Sorry.
That's NL8 on the top, right? On the face? Yeah. That's the big boy.
So
Cool.
I really like this because I could hook up a bunch of banana plug, what do you call this, probes, and it will work just like a regular continuity tester.
Cool. Very cool.
I definitely like how this is kind of regional, because in Florida, the blue one I just saw is the one I see the most out on the floor, and all you guys had different ones I'd never seen before, so that was pretty interesting.
That's
Go ahead,
cool.
Brian.
I'm sorry, I think I heard my name called. Somebody mentioned the rat sniffer. I don't think any of us has one, but essentially the idea is that it's a single-ended cable tester that's able to test for voltage across pins 1 and 2 and across pins 1 and 3 on a standard XLR. The nice thing is that basically every mixing console on the face of the planet will generate phantom power and essentially generate a signal for you to test. And if you put the sniffer on the other end of it, you can basically test. Extremely useful for like actually on a job site, actually on a show site, and somebody's on stage and they just need to basically test that the lines that are going to the console are actually on and working correctly. You don't need both ends of the cable. You just plug the tester into the input on stage. The guy at the mixing console turns Phantom on that channel, and if both of the LEDs light up, then you know that the line is working correctly. I'm not going to say that Dave Rat stole that idea from me, but I did build those before he made his, just for the record. But it's an old idea, but his works really well. And then he actually has a generator side so that you can use a generator and a receiver to test a line that you can't get to both sides to the same place.
And Marty's holding up a tone plug. I have one of those. They just need phantom power, and they can generate a whole bunch of different tone signals.
Great for on stage.
Yeah. Ed, did you want to go over the
and
box for about? You want me to go over this for about 2 minutes?
Marty, sorry, that has like just a little LED light at the basically at the butt of it, and that's how you. Correct? Yeah. Cool.
Right. Yeah, it's got an LED, so it'll show you. It turns on when it has phantom power, and it can produce 5 different sine wave tones, very low frequency subwoofer test tone, multi-frequency pulses, and a bunch of other kinds of tones. They're pretty cool.
Cool. Andy, go ahead if you want to show your cue box.
Okay. So this is something you're going to find in practically every workbox, audio workbox. It's so common. I'm not going to go through it in great detail. We don't have time here, but I'll go through the high points. So let me see if I can see this. Can you spotlight me so I can get a better view of this?
Of course.
Thank you.
Oop, I almost spotlighted the program feed. 1 second. That would have been fun.
So what most of us use this for is just to see if there's sound coming out of the other end of the cable. So I'll show you that really quick. I'm going to plug this in and just play something here. It has a little volume control here. So we'll turn that up. You hear a little music. All right, that part works. That's it, one of its main functions. So it has a speaker in it. It's very easy to blow the speaker up. This one is actually blown up. So it does that. It is also a tone generator. And so, in fact, I can use the speaker in it to show you that it has tone coming through it. I'll just turn this up. Oh, I lied. Hold on a second. I think I have, there we go.
Yeah,
there we go. So it has that. Nice I think that's a 440, by the way, just in case you're wondering.
Yep.
It has that nice little roll off when it turns off. Some other highlights of this are it will show voltage on your line. So you'll see some lights here. I'm going to plug in a cable.
Oh, good. I set mine up just in case you didn't have that ready to go.
There. You can see that this is just phantom power coming out of this Scarlett interface here, but that's what that is. It's showing voltage on that. It will show voltage on an intercom line, which is really useful because if you've like wondering, is this intercom on the other end of this? You plug it in there, either jack, and you will see voltage.
And what's really good about that is if you can see if if you only have voltage on pin 2 or pin 3. So if you have a bad if you're half legging your cable, so if one side of your balance line isn't working, or a line that you think should show up with voltage that doesn't, probably has a ground disconnected or lifted somewhere. Exactly. Because the phantom won't pass without the ground.
Yeah, or it's not turned on. This is a down and dirty intercom. It's got a mic built into it. If you have 2 of these connected to one another, you can talk to each other from backstage to front of house. That's rarely used it that way, but it is a nice feature of it. What else can I tell you? You can monitor what's coming across pin 2, pin 3, or both of them, pin 2 and 3.
Which is another good way, if you're not running phantom power, if you're actually listening to something, it allows you to listen to it, and you'll be able to hear if maybe one of your 2 pins is not, either pin 2 or pin 3 is not working. Yeah,
it has a headphone jack on it. It's a noisy headphone amp. I'll just say that right off the bat. This is not something you're going to want to use for critical listening situations, but you can hear if there's something on the line. It also has this other 1/4-inch jack, which I never use, but I believe this is for an tip sleeve mono IFB style connector.
I believe that's just parallel to the XLR connectors there, Andy.
It may be. I never use it, but yeah.
Show me yours again. Does yours have the little schematic? Yeah, it has on the little schematic. You can see it is for an unbalanced earpiece.
There you go. And I think that's the highlights of this thing. But it's a great test tool. I don't care how much digital you have in your system, you know, for signals. At some point it's going to go analog, and that's where this might come in handy.
Now, also on yours, I don't know if we have the same model. You have the little TT input next to the clip on the very top.
Oh, hold on.
Do you have it? Yeah.
No.
No, first generation had the TT. The second lost it.
Oh, he has. No, he has a hole. Mine's a second gen and has the hole.
I'm sorry, TT. What do you mean, TT? Tiny
Phantom
telephone?
plug.
Yep.
Oh no, I don't have that.
So on. Oh, I'm holding it, of course, upside down compared to you guys. But
oh, look at you.
It's got a little TT input. So if you have patch bays that we were talking about earlier, you can check in and hear out of a patch bay. You can test that signal too. Yeah, these things are super useful. Worth every penny.
It's also worth a shout out from the comms world, because what we said before, if you plug it into ClearComm, you're going to get voltage on pin 2. If you go into RTS, you'll see 2 and 3, and you can use that pin 2 or pin 3 monitor switch to pick what you want to listen into.
Yeah, it's a cheap speaker station, which is what it amounts to. I think these are about $220 street price.
I actually had to use one not that long ago, since the pandemic, on a show where there was a teleprompter operator, and we just didn't have any more backstage foldback monitors for the teleprompter guy. So I just put my cue box at his station and let him monitor right from there, because I didn't care how it sounded, and neither did he. Just needed to hear the dialogue. Cool. So thanks for that, Andy. So we kind of covered testing. We're getting close to 8:30. So I want to kind of speed round a little bit of what we're going to talk about next. And I want to make sure we leave enough time for Jason to talk about coax and some other cables. We've been mostly talking about connectors. So in lightning round fashion, some of the things we talked about earlier with quarter-inch cables could be speaker cable. It could be a connector used for speaker cable. The cable would be different, but the connector would be the same if you have something like that. I think Mickey had mentioned banana plug, which I don't have any of those here. That would be another connector you could use for speaker, but I don't advise it. The common one you might see are these. This is an NL4 connector. This is made by Neutrik. This one happens to be wired only with 2 wires in it, but it can handle 4 wires, which gives you 2 channels of speaker. So of speaker level signal. So you could use this if you have subs and tops that maybe the subs use pins, use 2 positive and negative, and your tops use 1 positive and negative. You can run both those signals through the same cable, jump from speaker to speaker. With some manufacturers do that, and some of them you have to kind of pay attention. What is the box wired for? If it's wired for 2 plus and minus or 1 plus and minus. The EAWs that I used to have at a job I worked at, were all backwards to what everything else was, and JBLs are different. And yeah, as Brian's holding his hands up, it all depends, which is a Mickeyism.
Yes.
There's also spade connectors, which you might see actually connected to your speakers. I don't have an example of that. Oh, and sorry, I mentioned when Mickey held up his tester, I mentioned NL8, which was that big boy. It's a much bigger connector. Mickey, if you have that, I'll spotlight you again real quick. So that would be an NL8 receptacle. So you would plug in a much larger than the NL4 I held up, and it has 8 conductors in it. So it can carry 4 speaker channels on 1 cable. And then I think on the side of that, you had the NL4, correct? On the bottom? Yeah. So that's what the thing I held up would plug into. It's a locking connector. You insert it and then give it a quarter twist, and it locks. So cool. Thanks, Mickey. Anybody have anything to add to that before any other speaker things that I'm forgetting about? Oh, RCA we mentioned could be a speaker cable, a speaker connector.
1/4 inch is often a speaker connector is the worst.
Yeah. And you know, to a point you made earlier, Marty, about how XLR provides more surface area for your physical connection than 1/4 inch. I don't remember where, it must have been in some Neutrik marketing material, but the Neutrik Speak-On connectors have 4 times the surface area for contacts that you do over a 1/4 inch connector. So there's good reason to use these connectors besides them being locking, which is a huge benefit, and watertight, I believe. Don't quote me on that. Some of them, right? So yeah, that these are what you're going to see most of the time these days. And this happens to be, I had some speakers that my amp was Neutrik, but the speaker had a 1/4 inch. So this is a female 1/4 inch adapter cable that I yanked out of an old amp rack just to be able to show you guys.
Also, no live conductors on a Speak-On, which if you're running a bunch of 100 watts in a line array, you can actually get meaningful amounts of power.
Right. Cool. Sorry. So we're going to skip over power section for any of you guys following along. So we all, I think we've all seen Ethernet connector, Ethernet cables. This is an RJ45 connector. This happens to be Cat6 cable, but it's an Amazon Cat6 cable. So it actually, when you look at the specs, it doesn't actually meet all the spec for Cat6A, which is what it was supposed to be. But RJ45 is the connector. It's little brother, if I can find my phone. Matt, what is this? It's a phone. I couldn't yank it out of the back because it was too tight of a connection. But the smaller phone jack.
RJ11.
RJ11, exactly. So those are some of the other connectors that we use. For networking, you might see an EtherCon, which I don't have one handy. I don't know if anybody has an Ether. Do I have it? No, I have one in the other room. I really should have grabbed it. But an EtherCon is another Neutrik product. It has that RJ45 in the center of it with a shell like an XLR that makes it a more robust locking type connector. Mickey, sorry, go ahead.
Yeah, in broadcast, at least in on film sets and TV sets, there's some very niche or esoteric connectors like what do you call this? XLR, 5-pin XLR, which is typically used for 2-channel audio between cameras and sound mixers. A lot of broadcast grade cameras have the 5-pin XLR female built right in, and also on cameras like the smaller RE cameras, the Alexa Minis and Mini LF, they use, it was mentioned earlier, LEMO, but typically on wireless packs they use the larger LEMO connectors. But for the cameras, for the RE cameras, they use these tiny 5-pin or 6-pin LEMO connectors, which are a pain to solder.
Yeah, no thank you.
Yeah, those are evil.
Too many of those.
Before I step too far away from where we were with those Speak-On connectors, because I just realized I had it out here. These are not a male female, so you can't connect these like you could an XLR. But they have couplers that you can make a Loctite connection between 2 of these, and then you've got a locked connector. So I just wanted to show that in case anybody wanted. I figured there might be someone who's like, hey, you didn't talk about the couplers. Yeah, we're not going to talk about older data control. People know about USBs. We're not going to talk about RS-232 today because we are running short on time. So why don't we go into cables, and let's start with Jason so we make sure we get his presentation. He put together something cool for us to talk about coax cables. So Jason, go ahead. Tell us about coax.
All right, thanks. Let me share my screen. Hope this works. All right, I just lost, I can't hear my own audio anymore.
Oh,
Can you hear me?
We can hear
we
you.
can. Yep, we can hear you.
Okay, well then I'll proceed. Let me call up my notes. Okay,
Cool.
so coax, guys, basically it's an unbalanced cable. Its signal travels on the center conductor and is referenced to shield. There's a very precise relationship between the conductivity of the core center conductor and the shield materials, the dielectric constant of the insulator, its dielectric properties, and the physical diameters of all those components. They're all related to each other, and that's what maintains a uniform impedance along the entire length of that cable at radio frequencies. And this satisfies the goal of matching the impedance of all system components in a high frequency transmission system, which can be radio frequency, it can be high speed data, any number of high speed alternating currents. The center conductor can be solid or stranded. The solid has a little lower loss, but stranded is more flexible and easy to work with if you're wrapping it every day. And I should mention, we're going to talk about loss a lot. Loss is an attenuation of power from any component's input to its output, including your cables. So when we talk about loss, that's what we mean. The shield on these things can be braid, foil, or both, and both is most desirable. You want 100% shield if possible. The dielectric can be a few different kinds. It can be air dielectric for low loss, and air usually has plastic spacers in it to hold those dimensions so that they're, again, held in place very precisely, or it can have a single filament of plastic twisted around the center conductor down the line. The dielectric can be solid polyethylene, or polyethylene foam, which low loss cables like LMR 400 use, or it can be Teflon, which is really stiff and expensive. So connectors are an integral part of a coax because, again, we're trying to maintain an even impedance all the way through our transmission system. So they have to maintain that physical and electrical relationship that the cable does. And poor termination of one of these coax connectors that you see here, these are the common ones we run into all the time. Poor termination disturbs that relationship, and that can mean a stray strand of wire inside the connector that doesn't make contact but is bridging the dielectric. A torn foil or a cold solder, a loose crimp or a pinched crimp, all of those things can goof up the impedance of the cable at that point. Some of these coax connectors have different impedance variants, like BNC is a great example. And you can see they're easy to identify. There are differences in the insulators that you can see here. 50 ohm usually has a white Teflon, acetal, or ABS insulator, while 75 ohm is usually air or solid polyethylene, which has that kind of clearish gray look. And BNC variants like this, they're physically compatible to connect without damage, but the mismatch causes losses in your system. So you want to look at these before you mate them.
And where would you use one over the other?
So 75 ohm, you're going to use mostly in video, word clock, or MADI, for example, whereas 50 ohm, you're going to use in RF systems like mics and IEMs. Intercoms. I have seen there one time I did see a mic system that used 75 ohm. It was MyPro, but it's very rare to see that.
And that's you meaning for antennas is what you're talking about,
right?
In those systems.
Absolutely right. The only time you're really going to see coax transmitting audio is in a digital format like MADI.
Great.
So AC alternating current flows through a conductor, and when it's flowing through a conductor at frequencies above around 20 kilohertz, it starts to radiate an electromagnetic field that easily propagates outward through space. So a coaxial shield traps that field inside the cable. So that reduces radiated loss from the cable, and it also reduces ingress of interfering fields into the cable. And both of those help reduce crosstalk from cable to cable and reduce interference in general in an environment. So one important thing about coax is it attenuates signal more per unit of length as the signal frequency increases. And all coax variants differ in that spec, and their manufacturers, they publish those specs. I was going to get a little more technical here, but we're short on time. So I think I'll leave it at that with this visual example, which is not to scale. You want all of your signal traveling inside the cable and not escaping, or else you're going to lose some of it before it gets to the other end. So here's what's important to know about coax. Any change in impedance along the length of the cable or anywhere in your matched impedance system causes signal to reflect back in the direction it came from. And the greater the change in that impedance, the greater the portion reflected, and the more abrupt that change, the greater the portion reflected. And any kind of change in the electrical properties of the materials or the dimensional relationships of those materials can cause that reflection point. Crushed cable, corrosion, abrasion, bends, kinks, water ingress, any of those things can cause a reflection point inside your cable and degrade your signal and cause a lot of loss. And in the case of when you're using a cable on a transmitter, that reflected power going back into the transmitter can blow up your transmitter. The transmitter can't handle dissipating that extra voltage and current as heat. So another common failure in your coaxes is pushed and extended pins. Always look at your connectors before mating. Extended pins can damage sockets. Retracted pins or sockets can cause an impedance change where the gap is and cause a signal reflection. And usually this is caused by repeated coiling and uncoiling of a cable, especially an airspace cable, where the center conductor can shift inside the cable and push that pin or socket in or out over time. So you always want to look at them, and you want your with BNCs and TNCs, you don't ever want the tip, and N actually, you don't ever want the tip of the pin to extend past the ground, the fingers on the ground ring, not ground, shield ring. And with the sockets, you don't ever want the socket to be pushed out past the face of the insulator. So do we have time for me to get into properly testing these, or should I wrap it up there with the general description?
I think in the interest of time today,
what do you think?
Yeah, I think in the interest of time today, why don't we take it here? Because I know we can get into pretty deep into testing if we go that route, and I want to make sure we cover a couple more things. We've only got about a little less than 15 minutes left. So if there's any questions too, I want to make sure we get to some of those.
Okay, then just let me sum up in a couple of words. When you're testing coax for high frequency, radio frequency, or high speed data, a continuity test isn't good enough. It'll tell you immediately if your cable is bad if you have a short or open, but it won't verify that the cable is good. To verify that the cable is good, you have to do some sort of sweep testing where you actually put a radio signal through the cable and measure what happens. That's it in a nutshell. So I think does that explain it pretty well?
I think so. Yeah, no.
All right, cool. I'll stop my share and hopefully get control of my rig back. I hope that was good enough.
No, absolutely.
Cool.
Yeah, kinks in a cable, are deadly for coax, right?
Absolutely. And that's why, you really got to watch your stagehands. You can bag them, guys, please handle these with kid gloves. But it's so easy to kink a cable when you're pulling it from a place you can't see it. If there's a loop in it and it's going around a corner, that kink can ruin it. Now, really good coax cables, like the foam dielectric type, sometimes you can reshape it and get some more life out of it and get it back into round, but it's really not great to do that. And it also permanently puts a little dip in your center conductor. Now, airspace cables like Professional Wireless 9046, you really got to handle carefully because that air spacing doesn't support the center conductor evenly all the way down. So it can develop a twist inside the cable that you never see, or kinks that you never see, that you can only verify during sweep testing. And also corrosion builds up in air spacing because moisture seeps into the inside the cable.
Now, so you brought up a point that I hadn't had on my outline that I guess I want to maybe kind of poll the panel for a second is, what's the proper way to wrap a cable?
Over under, baby.
Team
like
over
over
under. I'm
How
team
much
over
time do
under.
we have left?
I prefer under over, not over under.
Are you from
Can't even wrap it
Australia?
any other way now.
Yeah, that was kind of a loaded question that as Marty maybe I don't know if anybody saw what Marty was doing, but definitely the over the elbow is not the way to go with any of my cables ever. But yeah, that's ask enough audio people the right way to wrap a cable, you get a handful of different answers, but the correct one is over under. So cool.
And why?
Well, for a lot of the reasons Jason was just talking about, because you don't want to damage your cable. If you keep going over, you're going to keep twisting the insides of that cable. And we don't want twisting, as Jason was just telling us, because we don't want to misshape our conductors, especially on a solid core coax. But also even on a shielded, braided shield cable, the more you twist, you're going to fatigue that shielding, which then it becomes useless. It's going to allow, RF or EMI to enter, all this noise to enter your cable that you don't want. So when you do the over under, you end up twisting one way and then you twist the other way in 180 degrees. So it's kind of like that balance thing that we saw earlier that Justin Herminghaus showed us, is you put a twist in the cable, but then you undo the twist of the cable. So you're counteracting what you did, and it keeps the cable more laying flat. It makes it easier to throw out, when it's coiled and you want to toss it across stage, if you haven't ever seen anyone do that. And it's just better for the life of the cable. So I'm a firm over under every cable every time, unless you're figure eighting it, which is essentially the same thing in a lay flat sort of fashion. So
The other reason is that in a balanced wire, the conductors inside under the jacket are twisted within the jacket, and you want to maintain that those twists are part of the electrical characteristics of the wire. It affects the impedance, it affects the resistance, it affects the common mode rejection, that cancellation of noise that we talked about earlier. And if you wrench that wire, if you twist it around and you change the twist characteristics, the wire just simply won't work as well.
That's right. And Cat 5 actually has, if I'm not mistaken, each pair is twisted at a different rate. And if you disturb that, you disturb the balance of the cable.
Cat 5, Cat 6, Cat 7, the twists are actually, how many twists per inch are actually part of the cable's specification and are really important, because what Cat 5, 6, and 7, one of the things that that is different about them is the data rate. A Cat 5 can handle a 1 gig signal, Cat 6 can handle, and 7 can handle a 10 gig signal, mainly because of the number of twists and how the twists relate to each other between the pairs. So you don't want to disturb them.
yeah, that's all great information. Thank you, guys. We're gonna, again, in the interest of time, try to power through these last handful of things. Somebody earlier had brought up Star Quad. So maybe if we can talk just quickly about, two conductor versus the Star Quad, like as it for use in like an XLR cable. I forget if that was Andy or Andrew.
I wasn't saying I was the expert. I've just heard that the Star Quad is good for some things, but not good for other things.
And Marty has a spotlight. Marty there. He has an example of a Star Quad cable.
Star Quad is great in high RF noise environments because they excel at canceling out external noise. So a Star Quad cable is two pairs connected together. You'll get typically two white conductors, two blue conductors, or two of the same conductor, two same colors. And they get wired differently because so you'll get and they're arranged inside the jacket in opposing pairs. So you have this green and gray, and red and blue. And when you attach these or you solder them to an XLR connector, you'll take these two opposing connectors and wire them together, twist them together, and that becomes, say, your tip or pin 2. And the green and gray will get twisted together, and that will be your pin 3, sorry. And the shield will be your pin 1. And the way it works, this shows the way it works, is that when you have a radio frequency or some sort of external noise, it infiltrates the conductors evenly on this side and allows them to cancel out. Whereas in a two, if this were just a 2-pair wire like this, the noise source would infiltrate this one first and then this one later in time, and then it's a little bit more difficult to cancel them out. So Star Quad is good in high noise environments. Plus, you're getting that much more copper conducting your electricity.
And doesn't it have super low capacitance as a result?
It does have low capacitance, but it has, I think it's lower inductance, but a little higher capacitance because you have more surface area, more conductors that are close to each other. So a capacitor has conductors that are close to each other, but not quite touching. And so this has, 4 of these rather than 2 of these. So the characteristics are a little bit different than 2-conductor wire. I haven't really run into any situations where Star Quad wire would perform any less or
I think it's with AES. If you try to use it with an AES, it doesn't work as well as a normal mic cable.
And some older intercom systems, it induces noise. And I'm trying to remember if it was Clearcom or RTS. I can't remember, but I remember that it can induce noise, and you don't want to mix and match that cable with standard XLR coaxial cable.
Yeah, that's because the impedances between the conductors are extremely critical in both digital and balanced comms. Or no, I think isn't RTS an unbalanced comm?
Yeah, it's yes.
Great. So cool. Thank you for that, Marty. I didn't even know you were prepared with that at the ready. So thank you very much. We talked earlier about multi-pair cables like snakes, which everything Justin showed us earlier were multi-pair. Something we may have seen on show sites. What are show sites? Wait, does anybody remember what those are? Sorry. Are a stage box with a thicker snake cable. This happens to be an 8-pair. It has 8 channels. So these are what people are talking about when they talk about multi-pair or a snake. They can also be fantails. So instead of having a box at one end, it has sets of tails, on both ends. So like this, I have 8 channels and 8 channels. And one end is male, one end is female on this particular snake. Sometimes studio snakes, you might have TRS to either male or female XLR or TRS or TRS. I have insert snakes, like those insert cables I showed you earlier, that are a single TRS on one end to dual TS on the other end for multi-channels to make it less cabling and less to try to maneuver inside your racks. Speaker cable. So we talked a little bit about speakers. We didn't talk about speaker cable. So anybody want to grab onto anything speaker cable? Because I just feel like I'm talking a lot. Otherwise, cool. All right. So speaker cable. We talked a lot about mic cables. And we talked about them being shielded and being balanced. We talked about coax being an unbalanced, but as Jason mentioned, most of the time it's shielded with a center conductor. And like your guitar cables might be shielded and with a center conductor also. But then a speaker cable isn't a shielded cable. It's what we call an unshielded cable. So there'll be two conductors, but they won't have that braided shield around it that blocks RF noise and everything like that, because typically a speaker cable is carrying a lot more power and voltage behind it than our low level microphone inputs, or even our line level inputs between inputs and outputs and interconnects between certain gears. So it's less susceptible to picking up that RF and rejecting it. It does a better job rejecting it. Does anybody want to talk about maybe some of the things we consider with the thickness of our speaker cable? Oh, Jason.
I just wanted to add that one important thing too is with speaker cable, even if noise gets into the cable isn't carrying signal to another device that's going to amplify it another 50,000 times, like what's going into a power amplifier. So it's really immaterial at that point whether it's going to pick up any noise, because it's not going to get further amplified. And we're also very lucky that under 20 kilohertz doesn't tend to radiate into space very easily, because we're pushing lots of power down that speaker cable with no shield. If that was 100 kilohertz versus 20 to 20K, that cable would be a giant antenna.
Right. I don't know if my internet just got weird or if that was everybody, but no, absolutely. Thank you, Jason, for those are great points, that the speaker cable is already amplified to its max, whereas microphones, we obviously have to amplify those to get those levels where we need them to be. So, cool. Justin, go ahead.
I think a couple other things about speaker cable. One, we haven't talked about crossovers and dividing it up, but sort of like you can get into audio snakes, you can get into speaker snakes, where you're running 2 conductors or 4 because you're running, biamp doing 2, or, up to, well, here's a 19 conductor. But one of the other things with speaker cables, when we're talking about power cables, there's a lot in common, but when we're talking about power cables, we're worried about size in terms of how much power they can handle before they heat up and start a fire or melt. With speaker cables, you're both worried about drop over distance, but the other big thing we worry about is damping factor, which is when you're slamming a speaker cone around 220,000 times a second, it rings, it bounces around in the magnetic field. And part of what we count on to make speakers work is that we're able to control that. And if you ever try this, just take a raw speaker driver and tap on the cone, and you get sort of a very hollow, ringy sound. Then just take a piece of wire and short the 2 terminals on the cone and hit it, and you get a much heavier, sharper thud, because basically as the amplifier electricity makes a magnetic field to move the cone, it also provides a braking force. So how well our speakers perform relates to how well they're damped. So our amplifiers have very low resistance outputs. So having large enough speaker cable isn't just about power loss or heating. It also has a real effect on the quality of sound coming out of your speaker, because it affects the damping.
Great points. And affecting so not only the gauge, but the length of your speaker cables also affects how your speakers will damp because of the increased resistance over the length of the cable and the loss, right?
Yeah, general rule is you want to see less than an ohm of resistance across the length of your cable. And there's whole little calculators to figure out power and length and gauge.
Right.
It's also not a bad idea to periodically visually inspect the conductors inside your connectors on speaker cable and power cable, because if they're starting to discolor from heating and corrode, they can actually get more resistive over time.
Absolutely.
And begin to affect the performance of your system.
That was a great tee up too, because I took apart the that little jumper thing that I had to show what the back of the connector looks like. So this is that NL4 connector. It's got some cups where you can put the speaker wire in. This is a 2-conductor cable. So we have the +1 and the -1 on the NL4 connector, but there's no shielding. You can see these are 2 jacketed conductors. And then on what would be the 1/4-inch side, so pretend this wasn't a female 1/4-inch, it was a male. One conductor is to the tip, to the sleeve, and one is to what would be the tip connector. But it's an unshielded, no braided shield, just 2 wires side by side in a jacket. This happens to be a 16 gauge wire, and you would need different like we were talking about, different thicknesses, different wire gauges. And as we get lower in number, we get bigger in gauge. So we get a larger size. So a 12 gauge speaker cable will have a thicker diameter than a 16 gauge. Let's see what Justin's showing us.
This is a NL4 with 12 gauge. So it's larger wires and there's 4 terminals. So you have the 2 pairs.
Excellent. Yeah. This, as I said, this NL4 that I have is only wired for 2, but that would be a fully populated NL4. And as Mickey showed us the receptacle for an NL8, that would have 8 wires within connected to the one connector. So cool. We are pretty much over time today. So we left a lot on the table, unfortunately, but Omar, if there's any like last minute questions.
So I don't think I have any last minute questions. I do have some positive feedback.
Great.
I'm sorry. Did I ask? I did. Yeah. The last question we had was the tester one, and then everything else was just kind of chit chats on the side. A lot of comments about my pizza that I got over here that I haven't been able to eat yet, and then a lot of just kind of generic positive feedback that I'll share with you guys when we're ready for it.
I see that Leland Best in Facebook asked, what other factors can cause resistance on speaker cable besides length of the cable?
I missed that one. Sorry.
Yeah, he's sneaking them in at the end here.
Got it.
And then he also asked, what determines cable size? With a power cable, it's typical amperage. What about with sound? So he was asking questions about how we determine what cable size we need. And as Justin pointed out, the damping factor, just a loss over distance, those are some of those factors. And then what other factors cause resistance on a speaker cable besides length? Anyone want to grab that before we close it out for the evening?
The gauge of the wire would certainly affect the resistance. How well the solder joints are made will affect resistance. The age of the cable, oxidation, any kind of kinks, bends would affect the resistance of a cable.
And
Purity,
Brian?
purity of copper.
That's
Yep.
right. Yeah, now we're gonna get into audiophile territory with those debates. Those are very hotly debated things. If you have to have 99.99% oxygen-free copper cables, and there was a base forum years ago where that debate was constantly a topic, and one of the gentlemen on there actually made a cable just using a wire hanger for the conductor, and put up some sound tests and said what's what, and very few people could tell the 99% oxygen-free cable from his wire hanger cable. So take that with a grain of salt. But cool. So Omar, I think we might be ready for some positive feedback, if there is any feedback. Haha, very funny. But yeah, what do we got?
Oops, sorry about that. So Darren McGoldrick said, "Cheers, big fan here in Ireland." And I apologize, my screen's a little weird today because I'm using the Mac and not the PC. Alan Pitt said, "Thanks, great dialogue. You guys are great." Zach Swartz says, "Thank you, audio guys, for a great discussion." Leland says, "Size matters." Mike Grayhib said, "Thanks so much to each of you for sharing your time and expertise, insights. Greatly appreciate it." Leland again, I man would definitely knows his cables. And that's all I got right now. So
Cool.
unless someone's posting at the end here, which I'll double check.
Leland's just saying goodnight, I think, where we're at. But great. I would love to any final words from the panel before we call it a night. Anything that we missed about cables? I mean, obviously we missed a lot. There wasn't everything. We didn't get to everything. We didn't really talk about audio over IP cables or fiber. So we'll probably just have to invite you guys back and have another session about that, or we can all follow up in our Discord. I think most of our panelists are members of our Discord, so you can go over there and post in the channel for tonight's talk, and we can always continue the conversation there. I see a hand from Marty and then Mickey.
Yeah, final thought for me. I've been into places, especially churches, where volunteers don't really understand the respect that they really need to pay to their wires, because if you don't have working wires, you don't have an event, you don't have a service, you don't have microphones, you don't have outputs. Take care of your wires, they will take care of you.
Great point. Mickey?
Exactly what Marty said. Like, all our systems work because of all the cabling that connects them together. And it should be something, cabling should be something that should be a non-issue. We shouldn't have to like worry about cables working. They should always work. So take good care of them. And maybe on a later session, Jason had an excellent segment about coax, but maybe we can also in the future discuss the losses of coax over distance, and every single barrel connector that you use, every single splitter that you use adds a certain amount of loss in that. And I think that's crucial, especially in antenna systems.
Absolutely. Yeah. I kind of kept RF off of this table because we would need a whole show just to cover RF and antennas. So, which if there's interest in that, we're absolutely open for it. We can look at maybe May or June. I think we have a handful of things already. May is kind of shaping up, but we can look at that. We can bring somebody. We can bring Jason in. We can bring other RF people in and do an RF session. And then I know Justin and I have talked about doing comms as a separate thing. And I didn't really put them in Audio Month, just so you guys understand my thinking, because I kind of look at those things as audio adjacent, where everyone uses comms, so everyone should know about comms. And we're not the only ones who use RF either. We're just the ones who have to set it up for the most part. But I saw Leo and Andy's hands. Go ahead, Leo.
So really quickly, cheap cables cost you money. And if you have bad cables, the minute you suspect a cable is bad, destroy it. Don't actually let it back, because the number of times particularly you find that people then reuse a cable which you thought was bad, just cut the ends off it straight away if you've got bad cables.
Good advice. Go ahead, Andy Lipnick.
What Leo said, but also don't take for granted equipment that has cables plugged into it all the time. Like, so for example, if you get shipped a wireless rack and all the antenna wires are plugged in already, and they have been since the thing was built, and then you start experiencing problems. The first thing I do when I get stuff like that is I go in the back of the rack and I make sure all the BNCs are really seated, because I can't tell you how many times they'll pop out or get loose because this thing's been bounced around in a truck. Bear that in mind.
Yeah, everybody's going back into their venues and churches after, what, a year and a half almost? Yep.
Well, I mean, also as as Justin mentioned earlier about when he was talking about TT cables, and you always have to kind of give them a little twist, give them a little love, because those patch bays get oxidation on the contacts and things like that. So think about anything that's just plugged in for long periods of time, and especially if you're in any kind of humid environment, you want to make sure you exercise those cables, and sometimes even a little bit of deoxit or some other solvent. Although I don't like to put too much solvents on anything, because then you're starting to gunk stuff up. But if it's really bad, you can go that route. I saw Mickey's hand.
Yeah, I was about to mention the same thing. Contact cleaner, an old toothbrush, and a rag. A couple every few months, or here every few months because it's really humid. But if you see your connectors not shiny anymore, I think that's a good indication of just a little TLC.
Great. Jason, and then I think I did see Justin's hand earlier. Go ahead, Jason.
Test your cables. Test it after you repair it. Test it if you own a company. Put your cables on a testing rotation wherever so many times. Well, every time it comes back in the shop, test it before you put it back on the shelf. Don't make me find out that cable doesn't work when I'm 500 miles away.
Absolutely. There's one rental company that I won't name, but notorious, where every cable, I make sure I test before I put it in the air. I did a show where I was actually the projectionist. I hung 7 projectors, and there was no chance any of them were going up, and any of the cabling was going up in the air before I tested every one of those cables. Justin, I think I saw your hand earlier.
Yeah. We didn't really get to talk tonight about power or troubleshooting noise issues, but I just can't touch this without being on my soapbox, and somebody else just said about cutting ends off cables, which is safety grounds keep people alive. Don't ever sacrifice a safety ground for a noise issue. That's absolutely critical to people. Same thing if I see an AC cable with a ground pin broken off or missing, I'll just cut the end off. I don't ever want to see it go back in the system, because that's one of the few things in our business that is really life and death. So just can't talk cable without touching on that.
No, absolutely. Thank you for mentioning that. We did kind of skip over power. I had power on our list, but in the interest of time, we kind of skipped over it and stuck to the audio stuff. But no, those are absolutely vital points that you made there. So great. So on the point of death and dying, we'll wrap it up for the evening. And I want to thank our panel tonight. I want to thank Jason and Leo, Justin, Brian, Andy, Marty, and who just stepped away. Mickey was here.
Andrew.
Yep, they both had to step away. But thank you guys for all the knowledge you guys shared tonight. This was great. I know it might have been a little dry, but it's one of those things that if you don't know about your cables and how to keep them healthy, and what they're for and what they do, and as I said earlier, just because it fits doesn't mean it's the right cable. And I think Justin alluded to letting out the magic smoke, and that's something that very much can happen unintentionally. And when it does, it's definitely no fun. So before we wrap it up, Omar, what do you have this week on the podcast? Anything great coming up?
Yeah, so this week we have a good friend of mine who I work with a lot, Laura Massey. She's going to be on with us talking about virtual producing, and she's going to pretty much tell the stories and produce it for you guys to learn about that side of the industry, a little more about what they do on that end and how this is all working right now in the virtual side, how producers are kind of operating and doing things, and how she's been doing shows for the last pretty much 12 months now, virtually with the team, virtually everybody remotely working on shows. So we're going to bring her on for that. And then, Ed, you want to talk about what we've got going on Monday?
Yeah. So next week will be week 3 of Audio Month. And we're hoping to have our panelists here tonight return to talk about signal processing and effects. So what can you do to manipulate your audio once it's in your mixer or in your DAW? Things like EQ. What is EQ? Panning. And then things like compression and reverb, all that sorts of stuff. So bring those questions. I know that's probably going to be a pretty popular topic, and We're going to be fielding tons of questions. We'll try to have some examples of, maybe Brian, if you're around, can cue up some of the effects from the multitude of consoles you have sitting around. And we'll just talk about, all the different things in your signal chain that you can do to affect your audio. So that'll be fun. And then we'll tie it all together on week 4 with some routing and where you can send audio and what you can do with it. So next week is effects. Week 4 is going to be the more complex stuff. In week 4, the most requested thing we were asked when we put it out to the community was about mix minuses. So I'm putting that challenge out to our panel now. Somebody has to grab it, is building a mix minus. And maybe even a few of us can demo on a couple different consoles. I was thinking, maybe Brian on that D-Live that you have that's nice and shiny back there. We can have you do a mix minus there. Maybe I can show it on the Yamaha. If someone has an MRX32, we can show how similar and different those things are on those separate consoles. We'll come up with a great demo for that, because I think that's something that confuses a lot of people, and we want to try to demystify it. So with that, I also want to make sure that we thank the DVE store for their continued support of AV Tech Talks. If you're watching us, this broadcast is available in 1080p, and no matter where you're watching, if you're on Facebook or if you're on YouTube or you're here in the Zoom webinar. So that's all because of the great work that the DVE store is doing. They support us. So please go visit them, dvestore.com. Let them know that you heard about them from AV Tech Talks. They love to hear that kind of stuff. So thank you guys. And with that, I'm going to kick it back to our panel, and we're going to wave goodnight to Facebook and YouTube land. Thank you, everybody. Thank you for tuning in. We'll be back next Monday, 7 p.m. Eastern Time, and every Monday. So we'll see you guys next time.